Imagine navigating a busy city street with your vision reduced to shadows and blurs. For over 300 million individuals worldwide, this isn't imagination, it's reality. And among them, 1 in 12 visually impaired pedestrians experience either motor vehicle or cyclist collisions. Critical visual cues like traffic lights, hand signals, or even honking horns often fail to provide the necessary context for those with low vision or blindness. These cues are inaccessible, and their absence is a matter of life or death. For these individuals, every step outside can feel like a risk.
Traditionally, visually impaired individuals have relied on white canes and service dogs to safely navigate their surroundings. However, white canes are limited by its environment, and service dogs are costly and high maintenance. More modern assistive technologies such as OrCam and Envision AI are very expensive and have high learning curves for its users. We spoke with Andrew George from the San Diego Center for the Blind, who informed us about what current solutions are lacking.
What are some of the constraints of these solutions? Some big major problems they don't help with.
I think the lack of artificial intelligence. They are very much program based, and if you don't know the audio cues to work your way through the program, it can be really easy to get confused. So that is a huge challenge. Is just the navigation of the features is it takes memorization, and I would like to see something on the market that's a little bit more user friendly in the way where instead of the user following the program follows the user.
Our proposed solution is an attachable AI assistant device that ensures pedestrian safety for visually impaired people. Here is the CAD of our proposed device. Our product will be lightweight, user-friendly, and specially geared towards the visually impaired. For example, sound is crucial to their everyday lives. So we decided to incorporate bone conduction technology to prevent interference with their normal hearing. So here's a quick demonstration of one of the use cases of our product. So as you can see, we have the camera in the front, we have the hooks here, and we have the bone conduction device as well. So then I can hook it onto my glasses like so. So it'll go on very easily, just like that. And then now when I put this on my face, the bone conduction device presses up against my temple really nicely. So this is a demonstration of our automatic danger detection system.
Caution, fire hydrant 5 feet ahead. Walk 3 feet to the right to avoid it.
From a software perspective, what makes us stand out from our competitors is our proprietary Echo Score algorithm, which calculates the safest path for a user to take. First, we calculate the Echo Score for individual objects, which represents the safety of being near a certain traffic control device. We account for both the frequency and severity of pedestrian accidents, which is calculated using filtered and compounded data from the FARS dataset and the New York State Traffic Control Device Inventory. Then we use 3 rectangles, which represent possible walking paths, to calculate the safest path, which is the rectangle with the greatest sum of echo scores of the objects inside.
Since our device has low computing power, we decided to use edge computing. Our edge device sends image and audio input from the camera and microphone to the cloud. Our edge website retrieves this data from the cloud and uses Google APIs such as Gemini, text-to-speech, and speech-to-text in the cloud to generate output. Finally, our edge device receives audio output from the cloud and uses the bone conduction headphones to alert the user.
Now let's get into the business portion. Currently, the assistive technology market size is $22 billion. The visually impaired assistive technology market size is $4.2 billion. However, the market is inefficient since the products that are going around are limited in their scope as mentioned before. There are also around 32,000 optometric clinics in the USA, which makes the total addressable market very high. Our plan is split into 2 phases. Phase 1 is marketing. We are planning to make partnership deals with blind clinics, optometric clinics, centers, and communities, and test our product on these patients in these clinics. For example, we have a partnership with San Diego Center for the Blind. We will also make a social media account and advertise on this. Through our social media, we are also planning to interview many blind clinic operators. Overall, this will be a Series A fund, which we estimate to be around $150,000. Phase 2 will be where we distribute and scale our company. We will make more partnership deals with optometric clinics first and then partner with manufacturing companies while giving them 5 to 10% equity depending on how much they are willing to help us. This will help us scale and be able to make sales to clinics. Therefore, this will be a Series B fund in which it will require around $1 million.